Hello, Woodstock students. This is Mr. Brennan, and I'm sorry I can't be with you today. You may be able to hear my voice a little bit of stuffiness or weakness as I'm overcoming a head cold here. I'm hoping that this will turn out to be a relatively short but helpful video, instructional video for you to think about the next set of sort of analysis tricks that we need to master. Okay, so I hope you're ready to take ideas in and learn some new things, and then put those into practice right away. This here, right? There's some concentration math, and what that means is we're going to be looking at the ways in which you can compute the strength of a concentration. A salt or a sugar concentration will be typical for us to be thinking about, although it could be the concentration of hydrogen peroxide or the concentration of alcohol in water or so forth. But for this unit, we'll spend a lot of time thinking about the concentration of salt and sugar. Okay, so a couple of equations that are going to be essential. Okay, one is just computing straight up concentrations, like how do you know the concentration of a solution? You need to know two things. Okay, you need to know you need to know the mass that you're putting in, the mass in terms of the solute, okay, the solute mass. This could be either salt or sugar, right? And then you need to know the volume of the solvent, which would typically be water, okay? So you're just going to take the ratio of how much mass you're putting into how much water. Units that will express concentration in will be grams per liter, although other kinds of units can be used, okay? And the only tricky thing about this particular equation here is that sometimes the units for volumes won't match up. We'll see that in the practice problem we're going to do. Okay. Next up is looking at what happens when you try to take a known concentration and you try to dilute it down to some new concentration, okay? So here, I'll show you what this looks like, all right? It's all this, okay? C1 times V1 will equal C2 times V2. C will be the concentration, so maybe your starting concentration is C1, your final concentration is C2, and the volumes you're dealing with will be, the first volume and then the final volume, okay? The assumption here is that no new solute is being added. We're not adding salt, we're not adding sugar to whatever concentrations we're dealing with, just adding in more sugar or salt, okay? So that's a little typo there. No more sugar or salt, okay? So we're going to put both of these equations into practice right away. I'm going to show you how you can use both of these to make some sense of concentration problems. All right, supposing you needed to create 50 milliliters of a 5 gram per liter salt solution, how would you prepare it? Well, take a look, right? First of all, I want you to notice that we've got milliliters of volume and 5 grams per liter, a different kind of unit for volume. We're going to have to deal with that right away. But let's go right in. We're just going to use our first equation, right, that C is equal to M over V. And what do we know? Well, we know that the actual concentration we're shooting for is 5 grams per liter. So that's going to be on our left-hand side, okay, 5 grams per liter. And we know that just making a little quick correction here, sorry. We know that we're going to need 50 milliliters, that's our volume, right? Nope, I was right the first time, sorry. Feverish. 50 milliliters is our volume, right? What we don't know is how much sugar to put in. Now, I do want you to note that we have mismatched units, right? We've got grams per liter on the left-hand side, and we've got milliliters on the right-hand side. So in the next step, I'm going to make sure that they match, okay? Here's the way I'll do it. 50 milliliters is 50 out of 1,000, right? 1,000 milliliters would be 1 liter. So if I take 50 and divide by 1,000, that's going to be the correction that you would need to make to move things from milliliters to liters. Now I've got 5 grams per liter is equal to some unknown number of grams. divided by 0.050 liters. Now I've got matching units, okay? And if I continue, right, I want to get X by itself, but like all of these units are now going to just sort of get in my way, right? I know that my answer is going to be in grams. I've got grams per liter on the left-hand side, grams per liter on the right-hand side, okay? So those now match. So in the next step, I'm going to like drop the units, okay? So I just have 5 is equal to X over 0.050. That's a relatively simple problem to solve, right? To get X by itself, we're just going to multiply both sides by 0.05, all right? And we'll get a number then to put in to our 50 milliliters of water, all right? So bear with me while I make those quick edits there. And I'm going to get 0.25 grams would be X. So I would add 0.25 grams of milliliters, 0.25 grams of salt to 50 milliliters of water, okay? And that would give me exactly the concentration I need. Let's move to a second example here. And in this example, we're going to start out with a known concentration, and we're going to want to create a new concentration of water, of salt, sugar in this case, okay? So let's say we started out with 10 milliliters of a sugar solution whose concentration was 35 grams per liter. And let's say that was too rich, if you will. Let's say we want to create a concentration that was 20 grams per liter. How can we compute the new volume necessary to accomplish this? Okay, so we've already identified a first volume, like 10 milliliters of sugar, and a first concentration, 35 grams per liter. And we want to dilute it so that it has a new concentration. So this 20 grams per liter would be our V2, no, sorry, C2, our second concentration. So let's plug things in here, okay? We've got C1 times V1 will equal C2 times V2. Now, you'll notice, right, I've got grams per liter again, like we had earlier, right? Grams per liter here and milliliters there, right? And those are, in fact, mismatched, but I'm going to ignore that, and here's why. I hope you can notice that while I've got grams per liter on the left-hand side, I also have grams per liter on the right-hand side, right? And everything in this equation is just like a set of multipliers. So we can really just divide through if we'd like. We can mentally divide through by grams per liter, and it will disappear from both sides, okay? And that will mean that the volume, V2, that we compute, right, will be in milliliters, which is kind of handy for, you know, what we do in the lab. So I'm not going to correct for the mismatched units here, because in fact the concentration units are the same on both sides, and so I can kind of cancel them. Okay, let's keep going. Let's see what we get. All right, next step. I've gotten rid of the units. Okay, so I haven't really done anything there, but just, you know, shown those units going away. And now I can just kind of like isolate V2, right? I've got 35 times 10 on one side and 20 times V2 on the other. So I'm just going to go ahead and do 35 times 10 divided by 20, right? I'm dividing both sides by 20 to get V2 by itself. And when I'm done, right, I'm going to get an answer of 17.5 milliliters would be V2. Now, here's the tricky part, right? That's the new volume, right? But we started out with 10 milliliters of volume to begin with. So we're going to have that 10 and just add 7.5 milliliters to it to get to my 17.5, okay? So you've got to kind of keep your eyes open and your thinking going. There's a set of practice problems that get you working with both of these equations, okay? They're well worth trying right now. And we'll have a chance during class next week to double back and make sure that everybody's making sense out of this, okay? Good luck, and I hope this was helpful for you. Take care. Bye.